Welcome back to my channel. This is View 3ZAG Suraj here. Let's delve into the experience of procuring a cheap Neo-6M GPS module from Roborotin website, shedding light on the challenges and methods used to fix it. Here is a precise listing of the products from where I purchased mine. The Neo-6M module exhibits a peculiar behavior where it fails to communicate with UART when the antenna is connected. However, upon removing the antenna, NMEA messages were promptly received. Reconnecting the antenna results in the reception of proper NMEA messages and eventually the GPS locks on the satellites with correct LED indication on the Neo module. I have measured voltages in below 3 scenarios. First of all, I powered on the module with antenna connected and the observation was no UART messages. Voltage at the center pin of IPX, center pin solder point and ground was 0. With the same setup above, I removed the antenna without disturbing power supply. Here I got an interesting observation. UART messages started populating. DC voltage at the center pin of the IPX center pin solder point and ground was around 3.02 volt, followed by antenna port open message. The third scenario, I have reconnected the antenna back on the same port, after which I got a better NMEA messages with more information. When I measured the DC voltage at the center pin with respect to ground, it was around 2.82 volt. It is observed that the module was functioning till the next power reboot. After every power reboot, it was required to jack out and jack in the antenna port connection. I also attempted to replace the microstrip antenna, but the module exhibited the same behavior. Given that the GPS module came with a microstrip active antenna with built-in LNA, I suspected the issue might be related to DC bias voltage due to a faulty module. I gained some insight by referring to the pin definition in the datasheet. According to the datasheet, pin 11 is the RF input pin and pin 9 is the VCC RF bias voltage for the active microstrip antenna. Referring to the circuit diagram of the module, we can observe that pin 8 and pin 9 are interconnected, which is then linked to pin 11 via a series resistance R4 and an inductor L1. In this configuration, the RF signal travels from the antenna to the RF input pin 11. Upon inspecting the module hardware, I found that the resistor and the inductor were in place as per the specification. The main issue identified was that when the module was powered on, the voltage at pin 9 remained at 0 unless the antenna port was disconnected. Understanding that pin 23 is the VCC pin, I decided to ensure a continuous VCC supply to pin 9. For this purpose, I connected a diode IN4148 from VCC pin 23 to pin 9 VCC RF. This modification ensured that the DC bias voltage was continuously available for the active microstrip antenna whenever the module was powered on. This solution successfully resolved the issue, and to validate the fix, I kept the module powered and monitored UART messages continuously for 24 hours. Here is an illustration of the hardware modifications. As you can see, a diode is connected from the VCC pin to pin 9, ensuring a continuous DC bias voltage for the active antenna. To demonstrate this, I'll be using a serial to USB module along with a OTG adapter with serial monitor app on my phone. As you can see, the UART has started functioning autonomously, and NMEA messages are also appearing in the serial monitor. Since the setup is indoors, it took some time for the GPS synchronization, and position fix LED also began indicating its status. Hope you enjoyed this video. Thanks for watching 73s.